So it's an exciting day. First of all, we got propane out front, but right now I'm taking down this temporary water line because we have just pressurized the house water system. Well, the video this week is really a compilation of some pretty old videos. You'll notice I had that black eye that I had several months ago, and there are leaves on the tree. Well, it's Christmas time now, and we're just finishing it up because it took a long time to get all these pieces and parts together and actually get a functioning system. So let's take a look at it. The propane tank is installed outside, and I just want to show you how it comes into the house. It comes through the concrete wall right here after the regulator, of course, which is outside. And it comes into a very small manifold. We don't have a whole lot of appliances here on propane because we're using a wood-burning cook stove, but we have this line going all the way across the house and through the floor joist to the opposite side of the house for two things. First, there's an outdoor kitchen with a stove, which is critical right now because Danielle really wants hot cocoa. And then there's a T at the stove, below the stove, that allows us to go to a grill out on the deck that we haven't built yet. The second line comes out of here and goes across the ceiling over to our hot water heater. There is a third port that I'm not using. I wanted to put that in there because you never know what you might want to add in the future, so I always like to put at least one more than I actually need for future expansion. I have to basically try to adjust that and get that stabilized a little bit better, but I have it also grounded out on our grounding wire that goes out. We can go over here, it's kind of messy, but this is the line that comes down to the water heater and runs the hot water heater. I want to point out that we're using what is called, I believe, CSST. It's flexible gas line as opposed to the old black iron. Extremely easy to work with this, especially when you're looking at floor joists at 12 on center or 16 on center. This flexible line is able to be fed all the way through. It bends around corners. It's really kind of a do-it-yourself type of thing because in the very end you just put plates on it and they seal really easy. In fact, I only hand tightened them and they sealed just fine. But it comes in different thicknesses. I calculated that I needed 1/2 inch line, but I decided to go with a 3/4 line just in case in the future, if I need some expansion, I have that option because this goes all the way to the other end of the house. I think Danielle is out on the front porch. I'm trying to figure out what she's doing out here. What is this? What's going on here?
I'm making my first pot of morning cocoa on a real stove in my house.
This is not much of a house. You've got like stud walls and you've got building supplies packed up all over the place here.
It's a house.
This is not a whole lot of a house.
This is going to be the sweetest cup of cocoa and what are we at, like 14 months or something like that?
But it has a stove, so I guess that's worthy of an occupancy permit, right?
Yeah. Well, it is our summer kitchen and it's not quite winter yet. So.
We're getting there.
Slowly but surely. Oh, this is nice. I don't have to walk out to the grill to start my day.
Well, here we are in the basement utility room, and we're finishing up the plumbing, and one important thing are the drains in the basement. So I'm sitting by the ejector pit where all the drains in the basement go. You might have remembered we installed this when we had all the gravel on the ground and prior to pouring the concrete. So in order to keep it down, we filled it with rock and with water in order that it didn't float when that concrete was poured. So all the drains from the basement go into here. Then this pump will send them up that 2-inch tube right over to my 3-inch drain that leaves the house and goes into the drain field. And this is the pump that's going to pump that water out of the pit. This is a 24-volt pond pump. It's used on farms quite a bit. You throw it in a stock tank or whatever to drain the water out of it. Now the reason I went with this is because first of all it's DC powered, And second of all, it's a lot more efficient than the AC powered pumps there. It's also significantly cheaper. Now this probably won't last as long as some of the AC powered sump pumps, but at about $35 to $40, I can replace a lot of these for the price of a $200 or $300 sump pump.
One thing we'll never buy again.
Yeah. How does this work? Well, I have a float switch on it. Now, as the water level gets higher and higher, there's a big steel bearing in there. And as it gets higher, that bearing falls down and activates a switch that turns the pump on. And as the water goes down, you hear the ball bearing there hit the bottom and it turns the pump off. Okay, so I have about 12 inches of play there, which is roughly 13 gallons. So every time it turns on, it's going to pull 13 gallons out of there, and then it'll be set to take more wastewater. This pump's about 55 liters per minute, and that's around 14.5 gallons per minute, so it won't run very long. But that's at no head. It can actually, excuse me, lift 10 meters, and I'm only going about 3 meters up. So it's plenty of power to get it up there to my drain, and it's built for trashy water, so we'll see how it works. We're looking forward to getting this installed. Well, that pump went in without issue. I wanted to show you the complete setup and finished product that's been working for about 4 weeks now and just working fine. First of all, I have an access port right here. This allows me to check on the pump or the water level without opening this lid. This lid is sealed down with 4 bolts and some sealant, so I don't want to rip that up every time I want to check on things. So behind that, you have the outflow of the water with a check valve that keeps the pump primed by keeping water in that line. This is the vent line, and we have power to the float switch in the pump coming here, and these are some overflow drains from some other fixtures that we have going into there. All of this is sealed airtight, so all the venting goes through this pipe and out the attic. Well, Danielle's not real happy with me because I was working with the plumber and she was gone and I didn't get any video of what we did here. So this is the aftermath. The plumber was really kind of happy with the whole Flox block setup because you can just trench through and throw these lines and get your slopes. There's no slope in the water lines, but there's a slope in the vent line up here and a slope in the drain line down here. The other great thing is this hot water line, we could insulate it all the way through. There's styrofoam behind it and there's styrofoam in the front of it. And it really improves your efficiency when transporting hot water through the house. The drawback of this Fox block is, as you can see, these pipes are exposed. And if you put drywall up here and then you put a picture hanger or a screw or something, you're going to go right through these pipes. Now there's ways to avoid that by putting metal plates there or blockers or whatever, but the other way, which is what we're using, is we have taken pictures and we have taken measurements of all this, and we're collecting that so that when the drywall is up, we know exactly where those pipes are, and I think it's very important. The big question I get from every single person I talk to plumbing about is, why didn't you use PEX? Well, in short, I am just old school, for one. Copper has been around for decades and decades and over a century, and it works. It's reliable. The other thing is, copper is known to be, if you don't use lead solder, it's very clean. It doesn't have any chemicals in it. Now, PEX has already been shown to have some toxic chemicals in it. It's also been shown to have some other problems. It's new enough that we're not going to know these problems probably for another 10 or 20 years. And by then, I don't want to go in and strip my entire house because I found there's yet another chemical coming out of plastic that's going to poison us. I am a huge fan of copper, even though it's more expensive. It's very reliable and it's very safe. We have just turned water onto the house. We're going around to every one of these connections, making sure nothing leaks. We're checking all the outside spigots. Right now we don't have any leaks, so we're pretty happy with that. And then eventually, when I get the sinks in, I'll go to one sink at a time, hook them up, and get the faucet lines in, and then turn each sink on individually. So right now things are looking good. We have water in the house. Yay! A little trick I learned from my uncle. After I turn the water on and attach the fixtures, go ahead and lay a piece of toilet paper down there, because it's really easy to see a drop of water on toilet paper. And I'll leave that there for a day, and if I don't get any drops, then I take it out and we're good to go. Well, we've run into a little problem with our pump, the booster pump that is supposed to bring water from the cistern into the house with the pressure tank. It seems to be cavitating. I've been working with technical support for over 2 weeks now, and we can't find the issue. So, in our basement for several years has been sitting the backup to the backup to the backup plan, which is, this is a Bison hand pump, actually. And it's got, you can install it, and it is designed so that you can either bring the water out of the spigot, or you can hook that to a pressure tank and actually fill up your pressure tank. So luckily I have this, because I'm going to have to send that electric pump back, and we're not going to have any house water unless I get this hooked up. So let's see if I can do it. We completed the plumbing and the house was pressurized. Everything looked great except the pump was cavitating. Now, I worked with the company for several weeks and did a lot of troubleshooting, and they made the determination that I need to send it back. And we did so, but I realized that although I could install the manual pump, I didn't really want to manually pump the house for several weeks. So we used the 12-volt diaphragm pump that we had and thought, when the electrical pump comes back, we'll install the manual and the electrical together as one system. And it allowed me time to redesign the input from the water, because the company thought that that also might be one of the issues. Well, I love time-lapse photography. It makes things look so easy. I ran into a few snafus. I had to make a few changes to what I had laid out on the floor, but for the most part, it's pretty much what I established. We started here with water coming in to the house through a ball valve here, so I can turn it on and off. Goes through a priming port right here. Now you can't see it, but we'll go down below. That cross goes down to the manual pump, and then this side comes out to the electric pump. So let's go down below it. Follow this line here. As it comes down, it hits the 10 micron filter. Now the first thing you'll notice is this is suspended. It is not fastened to anything. The reason being is that the pump has a lot of vibration. And if you mount this to the wall, that vibration goes right through the wall, and you're going to hear it and sometimes feel it upstairs. So they actually recommended, if you could, to suspend it. What that does is allows the vibrations to be isolated to the pump, and it's a lot quieter operation there. So it looks kind of odd in here, but it's actually suspended. Now then it comes out of this pump and down around here and into the pressure tank. Now you're probably wondering what this crazy green hose is. Well, it's a garden hose that I had outside that I didn't actually buy a hose to go from the manual pump to here. I thought, well, let me just throw it on, make sure it works, and then I can design something later. And sure enough, let's start with the manual pump. If you get here in the back, I don't know if Danielle can video that, but it comes down from the cross through here and into the Y strainer. From the Y strainer, it goes down and comes right through the bottom of the manual pump. And then the manual pump, this is the cylinder where you pump with the piston in it. This allows water to bypass the spigot and come right down through a check valve. That's a 100 psi check valve. Comes down through the hose and into, this is the drain port for the pressure tank. So if I open that valve and pump, it will actually put pressurized water directly into the pressure tank, and it will bypass that other check valve that comes from the mechanical pump or the electrical pump. So you can have two inputs into the system. It can still operate as a drain also. So back up here to the manual pump. This, we're very happy with this. This is a Bison manual pump. We've had this for several years and never installed it. These are shallow well pumps, and I think the model number is 1900, but they don't actually make this one anymore. They make a different one. So the difference is the new one is one piece, this is two pieces. The advantage of this one is this has a higher capacity. So it takes about 5.5 pumps of the handle to get 1 gallon of water, whereas the newer one, it's about 9 pumps of the handle. Now I went ahead and tested this out, and I pumped it right up to 55 psi, and it wasn't that difficult, and it only took a couple of minutes. So I was super happy with the performance of this guy. And then you just take this cap off and you can fill a bucket or fill whatever you want from the spigot. So I'm super happy with this manual pump. In fact, the last 3 days, because I had to make a change to the filter, I have been pressurizing the tank solely with the manual pump and not allowing the electrical pump to do it. Connecting your pumps directly to the battery bank, it has its advantages. One in being that you can use very efficient DC pumps. But you want to protect your battery bank because that's more important and certainly more costly than the pumps. So this is a low voltage cutoff switch. If the voltage in the battery bank gets too low, it will cut off power to the pumps. Now, that's fine in my case because my pump has a manual backup on the pressure tank, so I can manually pump that up without any power at all. In addition, all the drain lines upstairs gravity feed into the main drain leaving the house. So the only drains that require any pumping at all are the ones in the basement. Upstairs, there's no power required at all. So the regular pump pressure tank works just like any other house, and you can fill a bucket like that, turn the shower on. But we can also manually get water right into a 5-gallon bucket if you'd like. And because of the leverage on this pump handle, it's super easy. I would say I'm putting probably a pound or two of pressure on there. And at 5.5 pumps per gallon, you can fill up a 5-gallon bucket pretty quickly. Well, it's unbelievable what plumbing and running water means to a family. We have lived in the RV for a long time, and now that we're back in a full house and we have a full house plumbing system, we know how spoiled Americans really are. Thanks for watching this week, and if you haven't subscribed, please do so and join us. If you have subscribed, leave a comment. We'd love to read them.